All right, welcome back to Trig. This is 6.4, Learning Target 6.4, learning how to use dot product with vectors and their applications of what we can do with the dot product. So last lesson we learned about vectors. Now this lesson we're learning about how we can combine them. There are two different ways you can combine a vector. One is with a dot product and one is with a cross product. We are going to strictly focus on the dot product. So when we write this, we're going to write just a generic vector. Let's just call him u, and we'll call him u sub 1, u sub 2, and then we'll have a v, and we'll call him v sub 1 and v sub 2. Now, if you do a dot product, we literally write it with a dot. That's where it kind of gives that. Sometimes this is also called scalar product because it gives us a scalar value. So we're going to go u dot v. And what that means that you're going to do is you're going to take the first component of your first vector, so your u sub 1, and you're going to multiply it by your first component of the second one, plus the second components together. So u sub 2 times v sub 2. And if you'd had a third piece, you could add that third piece in also. So if you had a 3D vector. So let's try some numbers with it. Let's let u be 2, 5, and then v, let's make him 7, negative 3. All right, so then to find the dot product of u dot v, we're going to take 2 times 7 plus 5 times negative 3, and that's going to give me 14 minus 15, so negative 1, and that's my dot product. So dot product, kind of a fast way to combine them. You're combining terms together, and you notice you get one answer. So that's another reason why it's sometimes called a scalar product, because it gives you a scalar as an answer. Okay, so we use a dot to denote it, and we get a scalar as the answer. A couple of properties that go with it is that it is commutative, and the fact that if you take u dot v, it's actually the same as if you do v dot u, so that's kind of nice. Oh, come on, properties. If we take u dot a 0 vector, we get 0 because you're multiplying everything by 0. If you take u dot u, so if you multiply it with itself, you actually get the magnitude squared, and so you get that. That's kind of another piece that's pretty handy. All right, so now formulas that we use with this, probably the most important formula we're going to use this is with the angle between. So angle between two vectors. So if I want to find the angle between two vectors, I have to use the dot product to do it. And so the formula for that is cosine of that angle. My S will become an S. So cosine of that angle equals u dot v, over the magnitude of u and the magnitude of v. So that's our formula. So if I wanted to find the angle between the two vectors that I did above, we could work this problem. We already know it's dot product, so we do cosine of theta equals that negative 1 that we had above. So this just came from here. Okay, we're just bringing that down. And then we're going to do the magnitudes. So the magnitude of u, remember, is the square root. It's like Pythagorean's theorem. So we take 2 squared plus 5 squared. So 4 plus 25, and we square root that. So we're going to have square root of 29 under here. And then we need the magnitude of v, which is the square root of 7 squared plus negative 3 squared. So that would be 49 plus 9, and square root of that. So square root of 58. Okay. Then we're going to do the inverse cosine on that value. So we're going to take cosine of theta. We're going to do the inverse cosine of the decimal. So let's plug that in, and let's see what I get. So negative 1 divided by square root 29. And that is a very small little negative 0.024. I take the inverse cosine of that answer, and we get 91 degrees. 91 degrees as my angle between these two vectors. All right, so that is super important. I want to make sure that you have that highlighted angle between formula written down so that you'll be able to reference that. Now with that comes a couple other nice properties. We often talk about wanting to know when things are perpendicular, and in vectors they call this orthogonal. So orthogonal, oh, come on. Orthogonal vectors are perpendicular to each other. This is helpful in physics. When you talk about the force vector, it's often perpendicular to the other vectors, or we talk about the way that heat emits in chemistry, then we want this perpendicular. Now, if something is perpendicular, then what do we know about their angle? Well, I know that their angle is 90 degrees, and cosine of 90 is our 0. And so therefore, if two vectors are perpendicular, then their cosine value would equal 0. So therefore, their dot product must equal 0. So if two vectors are perpendicular, then their dot product will 0. So if we know that their dot product is equal to 0, then we can get orthogonal vectors. And so that's kind of an important little piece that we'll want to use in the future. The other thing you're going to see with this is vector components. Like you can take apart a vector into different pieces, and we look at projections. So we look at, this is useful when we're talking about things like, say my vector is a plane flying through the air, and I want to know how much is to do with the gas and how much I'm pushing, and how much is to do with the wind. So we'll break apart a vector into different components. So you think of your u being broken into a first component, maybe a w sub 1, plus another component of a w sub 2. And so this is not the x and the y. These are both x's and y's and x's and y's. So it's like two different vectors put together to make your one. And we'll say that your w sub 1 is the projection of u onto v. And then vector w2 has to just be the difference. So it is your u minus your w sub 1. So it's whatever's left over. Now the formula for projection is the projection, oh, that's messed up, J. Projection of u onto v. So this may be my plane onto the wind. How much is the wind influencing it? Comes from the formula u dot v over the magnitude of v squared times my w, or times my v, sorry. So if I know the route that I want my plane to take, and I know the wind would be your v vector, you're going to see how much of my path is going to be controlled by the wind. If the wind is helping us, then it'll make how much I have to put gas-wise into it less. Think about like a boat on a river. That may be even easier for you to think about, how the current coming down the river will either help you or hinder you. So that's your projection kind of onto it. So let's do an example. Say our u is the vector, oh, come on, 3, -5. So this is where I want to go. And we're looking at the projection onto v. So maybe this is the case of the wind or something like that. And I want to know how much of it is controlled by that. Or maybe this is like pulling on a chain. You've got two different things pulling the same vector and you want to break it apart. So we're going to do the dot product. So we need u dot v, which remember is 3 times 6 plus -5 times 2. So 18 minus 10, or 8. So I have the dot product. I also need the magnitude of v. So the magnitude of v is that square root, Pythagorean's theorem, 6 squared plus 2 squared. So that's 36 plus 4 square root of 40. Now that one does simplify if you want to, or you can leave it square root of 40. It doesn't bother me, because at some point we'll probably be putting in to calculators. I'm going to go ahead and break that up into 4 and 10, to give me my 2 and 2, to make this magnitude. Oh, never mind, I'm not going to, because I'm getting ready to square it. Yeah, okay. So in the formula, we're going to square it. So I apologize for that misdirect. So our W sub 1, which is our projection, is our dot product, so 8 over the magnitude squared, so that's 40, times our vector V, so 6, 2. So 8 over 40 reduces. Let's reduce that down to 1/5, so my life's a little easier. And then I'm going to multiply that in, so that's 6 over 5 and 2 over 5. So there's my W sub 1. W sub 2 is going to be U minus that, so it's going to be 3, -5, minus my 6/5, 2/5. Let's make these out of 15, so this, or out of 5. This is 15/5. This is -25/5. So 15 minus 6 would be 9/5. And -25/5 minus 2/5, they'd combine, so -27/5. And there's my W sub 2. So now I have my two components of my vectors.